the ancient light in our night sky. At first glance, the moon seems so close, as if you could reach out and touch it, yet its glow comes from 250,000 miles away, a reflection of sunlight softened by distance. This light is ancient, not in age but in spirit. Every generation that has ever looked upward has seen this same face shining back. The first humans who kindled fires beneath the stars saw it. So did the first sailors who crossed dark oceans by its glow. The moon's light has outlasted empires, carried across the ages, as steady as breath. But it is also a reminder of impermanence. For even as it shines, its phases wax and wane. Its path slowly changes, and one day, far in the future, its distance will stretch beyond what we see now. Still, tonight it remains what it has always been, a calm guardian in the dark, whispering through light and shadow that we are part of something eternal. How the moon was born from cosmic chaos. Long before there was life on Earth, before oceans or continents, our world was a place of fire and collision. The moon's story begins in that chaos. Roughly 4.5 billion years ago, the young Earth was struck by a Mars-sized object, a world we now call Theia. The impact was unimaginably violent, tearing away part of Earth's crust and sending molten debris swirling into orbit. From that ring of shattered rock, gravity gathered the fragments, shaping them into the sphere that would become our moon. It was born glowing, hot enough to shine, a newborn satellite circling a wounded planet. Over millions of years, it cooled, its seas of magma solidifying into stone. And from that destruction, stability was born, a balance between Earth and Moon that would shape tides, climates, and perhaps even life itself. Out of chaos came companionship, a reminder that creation often begins in catastrophe. The giant impact theory explained. The giant impact theory remains the most accepted explanation for the moon's origin, and it ties Earth and Moon together more deeply than any other celestial pair. When scientists study lunar rocks brought back by the Apollo missions, they find the same isotopic fingerprints as those on Earth, the same oxygen, the same elements, as if the two bodies were siblings. This tells us that the moon wasn't captured or formed elsewhere, but born of the same materials that once made up our planet's surface. The impact itself may have tilted Earth's axis, giving us our seasons. Without that collision, our nights might be star-filled but moonless, and our world a very different place. In the moon's composition lies the memory of that ancient trauma, a record of fire and fusion, written across craters and plains. When we look up at it now, we are not just seeing a satellite, we are seeing Earth's reflection, frozen in stone. When the Earth had no moon, let's go back to a time before that great collision. When Earth was alone in the dark, without the moon, the planet's rotation was faster. A single day might have lasted only 6 hours. The tides were weak, stirred only by the sun's distant pull, and the night skies were vast and empty. The absence of the moon meant less stability. Earth's tilt wobbled wildly, swinging climates between extremes. The gentle rhythm of tides that would one day shape coastlines and guide life's evolution did not yet exist. And yet, it was this very loneliness that set the stage for change. When Theia struck, Earth's solitude ended. In the wake of devastation, a new partnership began, one that would temper the planet's spin, calm its chaos, and make it more hospitable to life. The memory of that moonless world lingers in the rocks, but its legacy is the balance we live with today. The moon's first glow, cooling from fire. Imagine the young moon after its birth, a sphere of molten rock, glowing red against the blackness of space. Its surface churned with seas of magma, its airless sky filled with vaporized stone. Over time, the fire dimmed, the molten plains cooled, solidifying into the gray highlands we now see. Volcanic eruptions reshaped its face, leaving dark scars, the lunar Maria, the seas that would later become familiar patterns to human eyes. As the moon cooled, it began to settle into its eternal rhythm, its orbit slowly tightening around Earth, the two bodies locked in their gravitational embrace. In that first cooling glow, there was silence, no wind, no waves, only the slow exhale of rock turning to stone. The moon's fiery birth faded into tranquility, a transformation from chaos to calm that mirrors, in some quiet way, the way all worlds and all lives eventually find their stillness. the everlasting dance between Earth and Moon. Think of the Earth and Moon as two dancers joined by an invisible thread, gravity, holding them in a slow, timeless waltz. Every night we see the moon drifting across our sky, but it is also pulling at us, subtly shaping the motion of our oceans and even the length of our days. This gravitational embrace keeps the moon locked to Earth, ensuring it always faces us with the same familiar expression. Together, they spin through space in near-perfect harmony, one turning, one circling, each influencing the other. Long ago, the moon orbited much closer, its pull stronger, its tides immense. Over eons, that closeness softened as energy from those tides slowly pushed it farther away, yet their connection remains unbroken. This celestial dance has lasted billions of years, quiet, patient, enduring, and though the steps are imperceptibly slow, the music of their motion will continue long after we are gone, two partners in an eternal rhythm written in gravity and time. Why the moon always shows the same face. At first glance, it might seem strange. No matter when or where you look, the moon shows us the same side. Its great gray plains and craters never shift, its features unchanging. This isn't coincidence, but physics. The moon is tidally locked to Earth. Over countless years, the tug of our planet's gravity slowed its rotation until it matched its orbit. Now, the moon takes just as long to spin once on its axis as it does to complete one journey around Earth. The result is a delicate balance, a face forever turned toward us, while the far side remains hidden. But though we never see the dark side from Earth, it's not truly dark. It receives as much sunlight as the near side, only hidden from our view. This perfect synchronization is another reminder of how deeply the moon and Earth are bound, not merely as neighbors, but as reflections of each other's movement, locked in mutual stillness. The hidden far side of the moon. For most of human history, the far side of the moon was a mystery, a realm of endless imagination. Artists and writers filled that unseen hemisphere with cities of glass, hidden civilizations, or seas of perpetual shadow. Then, in 1959, the Soviet spacecraft Luna 3 sent back the first grainy photographs, revealing a world far different from what we knew. The far side is rugged, scarred, and ancient, marked by countless craters and towering highlands. Unlike the near side, it has few of the dark, smooth plains called Maria, perhaps because its crust is thicker, less easily reshaped by volcanic flows. Even now, it remains a place of quiet isolation, shielded from Earth's radio noise, a perfect sanctuary for deep space observatories. When we think of the dark side, we might imagine mystery or danger, but in truth, it's just another face of the same companion, one that has always been there, waiting for our gaze to reach it. Lunar mountains taller than we imagine. If you stood upon the moon's surface and looked toward its horizon, you would see peaks rising sharply against the black sky, mountains as ancient as the solar system itself. The tallest of them, Mons Huygens, soars over 4,700 meters high, nearly half the height of Mount Everest. These lunar mountains were not pushed upward by tectonic forces like those on Earth. They were forged by impacts, sculpted by collisions with asteroids and comets billions of years ago. Around great basins, the shock of these impacts lifted ridges that froze in time, craters rimmed with jagged spires, cliffs stretching for miles. And because the moon has no atmosphere, no wind or rain, these shapes remain almost unchanged. To stand among them would be to walk through eternity, every boulder exactly as it has been for eons. The lunar mountains are frozen memories of violence, yet they rise in profound stillness, monuments to creation's chaotic beauty, standing watch over a world without sound. Seas that aren't seas. The lunar Maria. When you look at the moon, those dark patches that form the shape of a face or a rabbit are not seas of water, but vast plains of solidified lava. Early astronomers, gazing through primitive telescopes, believed they were oceans. Maria, the Latin word for seas. In truth, these regions were born of ancient fire. Billions of years ago, massive impacts fractured the crust, allowing molten rock from within to flood the surface. When it cooled, it formed basaltic plains darker than the surrounding highlands. The Maria cover nearly a third of the near side, while the far side remains largely untouched, a curious asymmetry that still puzzles scientists. Yet the Maria give the moon its familiar face, the one humanity has known since the first eyes turned upward. They are the scars of a restless youth, now softened by time. Silent seas, reflecting sunlight, echoing a history of fire long extinguished. The moon's serene expression, hiding a fiery past. The silent craters of cosmic history. Let's look closer at those countless circular marks that freckle the lunar surface. Each crater tells a story of a moment when the calm silence of space was shattered by unimaginable force. The moon, with no atmosphere to burn away debris, has been struck time and again by asteroids and comets for billions of years. Some of those impacts were small, carving shallow bowls. Others were cataclysmic, reshaping entire regions, flinging dust and molten rock for hundreds of miles. The largest of all, the South Pole Aitken Basin, stretches over 2,500 kilometers, one of the biggest impact structures in the solar system. Yet all of these scars remain perfectly preserved. On Earth, wind and water erase the past. On the moon, there is no weather, no erosion. Time barely moves. Each crater is a frozen moment, a page in the moon's silent history book, written not with ink, but with impact and fire. To gaze upon them is to gaze upon deep time itself, an unbroken memory of creation's chaos, resting in eternal stillness. What moon dust is really made of? When the Apollo astronauts first stepped onto the moon, they found its surface covered in a fine, powdery dust, soft underfoot, yet clinging to everything. Lunar dust, or regolith, is the product of billions of years of bombardment by micrometeorites. With each strike, the surface rock shattered and melted, ground into fragments finer than flour, but edged with glassy sharpness. This dust is a blend of crushed basalt, silicates, and bits of metallic iron. It sparkles faintly in sunlight, yet in shadow, it turns a deep silvery gray. Without air or moisture, these tiny grains stay untouched, sharp, electrostatically charged, eager to stick to suits, visors, and instruments. Astronauts said it got everywhere, in the creases of gloves, in the hinges of helmets, even inside their lungs. It smelled faintly of spent gunpowder, an odor born from the dust's chemical reaction with the moist air inside lunar modules. Each step on the moon stirred up that ancient powder, the ashes of a billion years of quiet impacts. The strange smell of the moon. It's one of those small, surprising details of human exploration. When Apollo astronauts returned to their landers after moonwalks, they noticed something unexpected. The moon had a smell. The scent clung to their suits and gloves, to the dust tracked back inside. They described it as the smell of gunpowder, or sometimes spent fireworks, sharp and metallic. Scientists believe the odor wasn't from the moon itself, but from a reaction between lunar dust and oxygen within the spacecraft's cabin. For billions of years, that dust had never encountered air or moisture, only vacuum. Once exposed to oxygen, its mineral surfaces released faint metallic compounds, producing that peculiar scent. It's a reminder that even smell, the most intimate of senses, can connect us to the wider cosmos. Imagine a smell born from stone that hasn't known air since the dawn of time, a scent of space itself, fleeting and strange, carried home on the boots of humankind's first explorers. How the moon shapes Earth's tides. If you stand by the ocean and watch the waves gently roll in, you are seeing the moon's invisible hand at work. Its gravity pulls on the water of our planet, raising great bulges of ocean that slowly follow its path across the sky. As the Earth rotates, different regions pass beneath these bulges, creating the rhythm of tides, the timeless breathing of the sea. Without the moon, our tides would be faint, driven only by the sun, much smaller, much weaker. The moon's pull stirs the waters, mixing nutrients, shaping coastlines, and even influencing the cycles of countless marine creatures. Coral spawning, sea turtle migrations, and the behavior of fish often align with the phases of the moon. It's easy to forget how connected everything is. The distant moon and the smallest creature beneath the tide. The gentle rise and fall of the ocean is a kind of heartbeat, a steady pulse linking Earth's living world to its silent companion in the night sky. The tides that slow down time. Here's a quiet secret about the moon. It is slowly changing the very pace of our world. The same tides that shape the ocean also act as a kind of brake on Earth's rotation. As the water shifts under the moon's pull, friction between ocean and land steals a tiny bit of energy from the planet's spin. That energy doesn't vanish. It transfers to the moon, pushing it slightly farther away, about 3.8 centimeters each year. Over eons, this exchange has lengthened our days. Billions of years ago, an Earth day may have lasted only 18 hours. Now, it's 24. The process continues, imperceptible but steady. The moon is both our mirror and our metronome, setting the slow rhythm of planetary time. Someday, long after we're gone, a day will stretch even longer, and the moon will drift a little farther. The universe always balances itself, motion traded for motion, energy for distance, like partners in an endless silent exchange. Why the moon is slowly moving away. It's strange to think that the moon we see tonight is not in quite the same place it once was. Each year, it drifts a little farther from Earth, about 3.8 centimeters, roughly the speed at which your fingernails grow. This gentle separation has been happening for billions of years. Long ago, the moon was far closer, looming large in the sky, pulling at the oceans with immense force. The cause of its retreat lies in the tides themselves. As Earth's oceans bulge toward the moon, their motion lags slightly behind its orbit, tugging it forward and giving it energy. That energy lifts the moon higher, pushing it outward into a wider orbit. Meanwhile, the Earth pays a small price. Its rotation slows. The days grow a little longer. It's a quiet, cosmic conversation between two worlds, written in the rhythm of time. One day, perhaps hundreds of millions of years from now, the moon will have drifted so far that total solar eclipses, those perfect alignments of shadow and light, will become impossible. A future without eclipses. Imagine a future sky where the sun and moon never meet in perfect symmetry. As the moon drifts outward, the balance of distance and size that allows total solar eclipses will slowly fade. The moon will appear smaller, unable to fully cover the sun's blazing face. Eclipses will still happen, but they will be annular, leaving a ring of fire around the moon's dark silhouette. The drama will soften, the wonder remain, but the perfection will be gone. On Earth, creatures that once paused under midday darkness will experience only brief dimming, the sun's fierce halo unbroken. Eclipses are fleeting miracles of geometry, possible only because our moon, though 400 times smaller than the sun, is also 400 times closer. That fragile coincidence is temporary, a cosmic alignment frozen in the age of humankind. We are fortunate to live now, in the era when the sky performs such delicate art. The future heavens will be beautiful still, but they will not be quite the same. The solar and lunar eclipses explained. At first glance, an eclipse might seem like an act of magic, the moon swallowing the sun, or the Earth's shadow devouring the moon. But it's simply a dance of geometry and light. A solar eclipse occurs when the moon passes directly between Earth and sun, casting its shadow upon us. In that fleeting moment, day turns to night, stars shimmer, and the air grows still. During a lunar eclipse, the positions reverse. The Earth slides between sun and moon, painting the moon with a copper-red glow as sunlight filters through our atmosphere. These alignments don't happen every month because the moon's orbit tilts slightly relative to Earth's path around the sun. Only when all three bodies fall perfectly into line does the shadow theater unfold. Each eclipse connects us to the ancient past, when early humans looked up in awe, and to the distant future, when others may do the same, still wondering, still watching, still dreaming beneath the moving light. The shadow that crosses the Earth. When a total solar eclipse sweeps across our planet, it creates something both haunting and exquisite, a moving shadow that races across the Earth's surface faster than sound. From space, astronauts see it as a dark oval gliding over continents, turning day to twilight in its path. Within the shadow's heart, the temperature drops, animals grow silent, and the world seems to hold its breath. For those who stand in the path of totality, the experience is unforgettable. A black sun wreathed in pale fire, the corona flaring in ghostly tendrils. The event lasts only minutes, yet time seems to dissolve in the strangeness of it all. For ancient peoples, this darkness was terrifying, a celestial omen. For modern observers, it's a reminder of the profound precision of our cosmos. The sun, the moon, and Earth, three bodies moving in perfect harmony for just a moment, a shadow that connects all who stand beneath it. Each one of us looking up together, hushed by wonder. How ancient civilizations worshipped the moon. Long before science explained orbits and light, The moon was a god, a guardian, a clock in the heavens. Civilizations across the world looked to it with reverence and fear. The ancient Egyptians saw in it the god Khonsu, a traveler through the night sky. The Greeks called it Selene, radiant sister of the sun. The Maya built temples aligned with its cycles, using its phases to guide rituals and harvests. In China, the moon festival celebrated its full face with lanterns and sweet cakes, a symbol of reunion and reflection. Every culture found meaning in its glow: love, rebirth, the passing of time. The moon, constant yet ever-changing, was a mirror for human imagination. Even today, when we understand its dust and craters, it holds a quiet power. When it rises full and bright, people still pause to look up. We still whisper wishes, still feel something ancient stir, that soft, eternal pull between the human heart and the night sky. Lunar calendars and the first concepts of time. Let's travel back to the earliest nights of humanity, when the world was dark and unmeasured. Before clocks, before calendars, people looked up and found order in the sky. The moon's steady rhythm, waxing, waning, disappearing, and returning, became our first measure of time. A month, from Mund, was born. Hunters and gatherers carved notches into bones to track the moon's phases. Farmers planted and harvested by its light. Priests and storytellers marked sacred days when the moon grew full, believing it to be a bridge between earth and the divine. In many ancient languages, words for month and measure share the same roots. Even today, the lunar cycle quietly shapes our lives, in rituals, in festivals, and in tides that pull unseen beneath the surface. The moon taught us to count, to expect, to wait. From its glowing face came the first sense that time could be known, that change could have a rhythm, that life itself could move in circles rather than chaos. Myths of the moon, gods, lovers, and legends. Every culture has told stories about the moon, and in every story, it feels alive. To the Greeks, she was Selene, radiant and graceful, driving her silver chariot across the night sky. To the Norse, Mani rode his shining path, pursued by wolves. In Hindu tales, the moon was Chandra, a god of beauty and fertility, adored by all. In Japan, the moon was home to a rabbit pounding the elixir of immortality. The Aztecs believed a brave warrior became the moon after being struck by the sun's rays. And in countless legends, the moon was a lover, forever chasing or being chased, bound by longing. Perhaps it's because its phases mirror our own moods, waxing with hope, waning with sorrow, vanishing into darkness only to return anew. The moon's face is the face of emotion itself, calm, luminous, and yet marked by shadow. To tell stories of the moon is to tell stories of the human soul, projected into the heavens, how the moon influenced sleep and dreams. There's an old superstition that the full moon stirs the mind and makes sleep restless. And while the myth endures, modern research suggests there might be some truth to it. Studies show that people often sleep slightly less deeply during the full moon, perhaps due to its brightness, or an ancient biological rhythm we've long forgotten. Before electric light, moonlight was powerful enough to transform the night. Under its glow, hunters could travel farther, lovers could meet in secret, and storytellers could gather their circles. Dreams seemed to shimmer with a different kind of clarity then, touched by that silvery radiance. Even now, on bright nights, people report more vivid dreams, more strange awakenings, more moments of quiet introspection. The moon may not control our thoughts or fates, but it reminds us how deeply light and rhythm shape our minds. It's a quiet partner in our sleep, one that waxes and wanes outside our windows while we drift in and out of our own inner tides. For centuries, people have claimed that the moon influences human behavior, that full moons bring madness, birth, violence, or passion. The very word lunatic comes from Luna, the Roman goddess of the moon. Hospitals and police stations once reported busier nights during full moons, though later studies showed those patterns were often coincidence. Still, the belief endures, woven deep into culture and language. There's something about that silver light that feels powerful, stirring, uncanny, and perhaps there's a poetic truth behind the folklore, that the moon reminds us of our cyclical nature, our highs and lows, our waxing energy and waning calm. Like the tides, our emotions rise and fall, drawn by forces we can't always name. Whether or not the moon truly moves our moods, it reflects them beautifully. Each phase mirrors a different kind of feeling, and in its changing face, we see ourselves, shifting, luminous, and always returning to light after darkness. The moon, through early telescopes. When the first telescopes turned skyward in the 1600s, the moon revealed itself not as a perfect heavenly sphere, but as a world of rugged mountains and deep craters. Galileo Galilei was among the first to draw what he saw, light and shadow sculpting a landscape, through his small lens. He realized the moon was a place, not an ethereal lamp. Its peaks caught sunlight. Its valleys fell into blackness. Humanity's perception of the cosmos changed overnight. The moon was no longer just a symbol of mystery or divinity. It was a physical world waiting to be known. Later astronomers refined these drawings, mapping craters and plains, naming them after philosophers and poets: Copernicus, Plato, Tycho. Each name became a bridge between imagination and discovery. Those early sketches, simple yet profound, were humanity's first intimate portraits of another world. In every line and contour, they whispered a truth that still humbles us. The heavens are not distant. They are places we can reach. The first drawings of lunar craters. In the early 17th century, before photography, astronomy was a craft of the hand and the eye. Through fragile telescopes of glass and brass, astronomers peered into the trembling image of the moon and recorded what they saw with pencil and ink. Galileo's sketches were the first, but they were followed by ever more precise renderings, each crater and mountain carefully captured, each shadow revealing a little more of the moon's texture. These drawings were acts of reverence as much as science. Johann Hevelius spent years producing his Selenographia in 1647, an atlas of the lunar world. Others followed: Riccioli, Cassini, and Schroeter, each mapping what they could see, naming features after great thinkers of Earth. These early observers could not travel there, yet they traced every valley and ridge as though they might someday walk those silent plains. Their sketches transformed the moon from a distant mystery into a landscape of familiar beauty, a world of light and shadow rendered by patient human wonder. The race to reach the moon begins. Centuries later, what had once been mapped by candlelight became the dream of rocket fire. In the mid-20th century, a new race began, one not of nations alone, but of imagination. The Cold War kindled a fierce competition between the United States and the Soviet Union, each seeking to prove its reach beyond Earth. The first milestones came quickly: the Soviet Luna 2 crashing onto the moon's surface in 1959, the first human-made object to touch another world; Luna 3, sending back ghostly images of the far side, never seen before. Then, in response, America's Apollo program was born. Vast, dangerous, almost impossible. Engineers, scientists, and dreamers worked around the clock, building machines that could carry fragile human bodies across 250,000 miles of empty space. The race to the moon became more than politics. It became humanity's first great attempt to step into the heavens, to transform ancient wonder into motion, myth into reality. The Apollo missions that changed humanity. Between 1961 and 1972, the Apollo program unfolded like a modern epic. Apollo 8 first carried humans around the moon, giving us our first view of Earth rising above the lunar horizon, a fragile blue marble suspended in blackness. That image alone shifted human consciousness. Then, in July 1969, Apollo 11 touched down. Neil Armstrong and Buzz Aldrin stepped into the gray dust, their voices calm but trembling with awe. "That's one small step for man," Armstrong said, "one giant leap for mankind." Over the next missions, astronauts explored craters, deployed instruments, and collected rocks older than any found on Earth. Each journey added another chapter to the story of exploration, each footprint another symbol of what cooperation and curiosity could achieve. The moon, once worshipped and feared, had now been touched by human hands. It changed how we saw the cosmos and how we saw ourselves. We were no longer just inhabitants of Earth. We had become visitors of another world. The first footprints in lunar dust. When the Apollo 11 astronauts stepped down from the ladder, the first thing they noticed was the texture of the ground, soft, yielding, like powdered charcoal. Their boots pressed deep, leaving crisp, unchanging prints in the dust. Without wind or rain, those impressions remain even now, perfectly preserved. Every tread and scuff, every mark of exploration, lies silently beneath the black sky. The lunar soil held those moments like a photograph that will never fade. Imagine that. Human footsteps, undisturbed for over half a century, and likely for millions of years more. The act of walking, something so ordinary on Earth, became profound on the moon. Each step was taken in slow motion, framed by the vast emptiness of space, each movement a testament to human fragility and courage. On that quiet world they left no sound behind, only traces of presence, fragile but eternal, whispering across time that humankind once reached beyond its home and touched the infinite. The fragile flag that still stands. When the Apollo missions ended, 6 American flags remained planted in the lunar dust, slender poles in bright fabric set against the endless night. The astronauts knew the sunlight there was fierce, the vacuum unrelenting. Over decades, those colors have likely bleached white, the fabric stiff and brittle. Yet at least some still stand, their shadows visible in satellite images. They are symbols not of conquest, but of curiosity, reminders that humanity, for all its chaos, can aim upward and achieve something delicate and extraordinary. Imagine those flags now, motionless, untouched, standing under a sky where the earth itself rises and sets. No wind stirs them, no decay consumes them. They are as silent as the craters, as still as the stars. On a world without air, even time seems to hold its breath. Those flags endure, not for glory, but as emblems of wonder, small, fragile testaments to a moment when humanity dared to dream and succeeded. How we collected moon rocks. The moon rocks that rest in laboratories and museums today are among the most precious materials ever touched by human hands. Between 1969 and 1972, the Apollo astronauts gathered more than 380 kilograms of lunar material, stones, dust, and core samples drawn from beneath the surface. They chose sites carefully, guided by geologists on Earth, searching for clues about the moon's origins. Each sample was sealed in sterile containers, protected from contamination. When they were returned home, they told stories older than any mountain or sea. These rocks are ancient, some dating back over 4.4 billion years. Relics from the time when the moon itself was still molten. Under microscopes, scientists found glassy beads formed in volcanic eruptions, crystals cooled from lunar lava, and grains of material blasted into space by impacts. The moon rocks revealed that its composition closely mirrors Earth's mantle, confirming their shared past. To hold a piece of the moon is to hold a chapter of creation, silent, weightless, and impossibly old. What moon rocks taught us about Earth. The moon, though small and barren, turned out to be a mirror of Earth's earliest self. When scientists studied the Apollo samples, they discovered that lunar rocks were chemically similar to those found deep within our planet. This was a revelation. It meant that Earth and Moon were once part of the same body, born from a single violent event. By examining isotopes of oxygen and other elements, researchers could glimpse the solar system's early chaos. When worlds collided and merged, the moon's lack of atmosphere and geological change preserved those early records perfectly, offering a window into a past Earth had long since erased. From the moon's surface, scientists learned about volcanic activity, solar radiation, and the long history of meteorite bombardment. In many ways, the moon became a time capsule, one that allowed us to look backward 4 billion years, to an age when Earth's crust was still forming and the first oceans were just beginning to appear. The cold, silent vacuum of the lunar surface. The moon's beauty hides its hostility. On its surface, there is no air to breathe, no wind to carry sound, no water to quench thirst. The sky above is a black void, even when the sun burns high. Temperatures swing from blistering heat in daylight, over 120 degrees Celsius, to deadly cold at night, plunging below -170. Every footprint, every tool mark, exists in absolute silence. Without atmosphere, the horizon appears sharp, the shadows deep and endless. Time itself feels different there. The lack of air means that even a whisper cannot travel. The astronauts spoke to each other through radio only, their voices floating through static. And yet, within that emptiness, there is a peace, a stillness, so complete that it almost feels sacred to stand there, surrounded by infinite blackness and the distant glow of Earth, is to understand both isolation and connection in their purest forms. The moon is lifeless, but profoundly alive in its silence. Why the moon echoes when struck. One of the strangest discoveries from the Apollo missions came after the astronauts left behind seismometers, instruments designed to measure moonquakes and impacts. When mission controllers deliberately crashed parts of the spacecraft onto the surface, something unexpected happened. The moon rang, not like a bell exactly, but in a long, lingering vibration that lasted for nearly an hour. On Earth, seismic waves fade quickly as they travel through molten layers and water-filled rock. The moon, however, is dry, rigid, and fractured. Its vibrations travel farther, echoing through the crust like ripples in glass. This eerie resonance revealed that the moon's interior is far less active than Earth's. No flowing mantle, no deep tectonic churn. It's a world that has cooled and solidified, its heart stilled, and yet when struck, it sings softly, a haunting reminder that even in silence, even in stillness, there are echoes of the past, whispering through the bones of an ancient world. Could the moon have hidden water? For a long time, scientists believed the moon was utterly dry, a world of dust and stone with not a drop of water to be found. But over the past few decades, that belief has changed. Instruments aboard spacecraft, such as India's Chandrayaan-1 and NASA's Lunar Reconnaissance Orbiter, detected signatures of water molecules trapped in the surface regolith, particularly near the poles. In deep, permanently shadowed craters, where sunlight never reaches, temperatures plunge so low that ice can endure for eons. These frozen pockets may be remnants of ancient comet impacts or outgassing from the moon's own interior. It's a revelation that changes everything. Water means potential, for fuel, for life support, for the future of exploration. Beneath the dust, the moon may hold a record of the solar system's watery origins, preserved in shadow. In those dark craters, untouched since the dawn of time, lies the promise of tomorrow. A reminder that even the most barren worlds can hide secrets of extraordinary beauty. The discovery of lunar ice in craters. In the shadowed depths of the moon's polar craters, a remarkable secret lay hidden for billions of years. These craters, permanently shrouded from sunlight, maintain temperatures so cold that ice can survive indefinitely. Early 21st century missions, including NASA's Ellscross and India's Chandrayaan-1, revealed deposits of frozen water, tiny grains tucked into the regolith, some forming thin sheets, others mixed with lunar soil. This discovery reshaped our understanding of the moon, transforming it from a dry, barren landscape into a place with potential resources for future explorers. Ice in these craters is more than curiosity. It is a key to survival. It could be melted into drinking water or split into hydrogen and oxygen to fuel rockets. The moon, long viewed as a lifeless companion, suddenly seemed a stepping stone for humanity, a bridge to the planets beyond. In its eternal shadows, ice whispers the quiet promise of possibility, patiently waiting for the first hands bold enough to harvest it. How future colonies could use lunar ice. Imagine astronauts landing on the moon, not just for exploration, but for settlement. Lunar ice could become the lifeblood of these colonies. It could provide clean water for drinking and growing plants, creating self-sustaining habitats under protective domes. Hydrogen extracted from water could power fuel cells, while oxygen could replenish breathable air or serve as oxidizer for rockets bound for Mars or beyond. Each polar crater might serve as a natural reservoir, offering supplies that Earth could never send efficiently across space. Engineers are designing equipment to melt, purify, and store ice, imagining habitats illuminated by artificial suns, while cold, untouched water lies just meters away. The moon transforms from a passive observer of Earth to an active partner in humanity's journey. Its frozen resources may be the foundation upon which we build our future, a quiet gift from a world that has silently accompanied us for eons. The challenges of living on the moon. Yet life on the moon is far from easy. Gravity is only 1/6 that of Earth's, altering movement and muscle strength. Radiation from the sun and cosmic rays bathes the surface, demanding shielding and careful planning. Temperatures swing wildly, from searing heat during the day to extreme cold at night. And then there is the dust, fine, jagged, and pervasive, clinging to everything, infiltrating seals, electronics, and lungs. Even the act of walking leaves particles in the air that can cause abrasion and respiratory irritation. Every step, every breath must be calculated. Lunar dust is deceptively quiet, yet it is one of the most relentless hazards for colonists. The moon is beautiful, yes, but it is a world that demands respect. Its silence is not empty, it is vigilant, reminding all who land there that survival is not a given and that every endeavor requires patience, ingenuity, and humility. How moon dust could damage spacesuits. The astronauts who first walked on the moon quickly learned that its dust is not merely an inconvenience. Lunar regolith is jagged, electrostatically charged, and abrasive. Boots and gloves become coated. Dust penetrates joints, and repeated contact can wear down layers of fabric and metal. During the Apollo missions, fine particles infiltrated helmets, visors, and the seals of the lunar modules, scratching surfaces and creating persistent maintenance challenges. Future explorers may face even greater problems as longer stays increase exposure. Dust can interfere with life support systems, reduce insulation, and even threaten the integrity of suits. Engineers are designing new fabrics, magnetic repelling coatings, and filtration systems, learning from the lessons of the past. Living on the moon is a dance with dust, a reminder that beauty can be dangerous and that every step in its powdery surface carries a hidden cost. The moon's surface is a companion of wonder, but one that requires constant care and respect. The vision of lunar bases and observatories. Despite the challenges, humanity continues to dream of establishing a permanent presence on the moon. Bases could rise near the poles, where sunlight is nearly constant and ice can provide vital resources. Observatories might peer into deep space from the moon's far side, shielded from Earth's electromagnetic noise, offering the clearest view of the cosmos. Scientists envision laboratories, greenhouses, and habitats built to withstand radiation and temperature swings. Robotic assistants could handle routine tasks, while humans explore craters, mountains, and Maria, conducting experiments impossible anywhere else. The moon becomes both a laboratory and a gateway, a platform to learn not just about itself, but about the wider universe. Its barren plains, once silent and untouched, could hum with activity, yet always under the watchful eye of the stars. Here, imagination meets reality, as the quiet satellite of Earth transforms into a place of discovery, innovation, and connection. Using the moon as a gateway to Mars. The moon is more than a destination, it is a stepping stone. Its low gravity makes launching rockets far easier than from Earth, requiring less fuel to escape into the cosmos. Scientists and engineers envision lunar bases serving as launch pads for missions to Mars and beyond. Water ice could be converted into hydrogen and oxygen, fueling spacecraft without the immense cost of lifting supplies from Earth. Lunar habitats could train astronauts in long-duration life support, radiation protection, and isolation, conditions that mimic those of deep space travel. By learning to live and work on the moon, humanity gains the experience necessary for the far longer, more perilous journey to the red planet. In this way, the moon transforms from a quiet companion into a cosmic ally, a place where lessons of survival, exploration, and ingenuity can be honed. Every crater, ridge, and shadowed valley may become a classroom for understanding how we will venture into the wider solar system. The moon's role in future space travel. Beyond serving as a gateway, the moon could act as a refueling station, a communications hub, and a scientific observatory. Its regolith could provide shielding for habitats or radiation-sensitive equipment. Its stable surface offers opportunities for telescopes far from Earth's atmosphere, where stars shine without interference. Imagine solar arrays gathering energy from constant sunlight, powering research stations or transmission networks across the solar system. By mastering life on the moon, humanity prepares for the complexities of interplanetary travel, how to manage resources, recycle air and water, maintain equipment, and endure months or years of isolation. The moon's quiet presence teaches patience, engineering, and the delicate balance required to survive beyond Earth. It is both a laboratory and a partner, shaping our ambitions and revealing the possibilities of what comes next, quietly supporting us as we reach farther into the cosmos. Strange magnetic fields on the moon. Though small and long thought inactive, the moon holds mysteries deep within its crust. Some regions exhibit magnetic fields, weak yet surprisingly structured. Unlike Earth, which generates magnetism through a molten core, the moon's magnetism is patchy and uneven, likely remnants of an ancient magnetic dynamo that has since faded. Scientists study these anomalies, wondering what they reveal about the moon's fiery past. Could impacts, molten flows, or solar wind interactions have left these subtle traces? These magnetic islands offer clues to its interior and formation, hints of a world that once roared with energy and now rests in silence. Even in its apparent stillness, the moon carries a hidden vitality, an echo of processes long past. a whisper of power that shaped its surface and perhaps influenced the particles and radiation flowing around it. Mysterious moonquakes that still occur. Though the moon is geologically quiet, it is not completely still. Seismometers left by the Apollo missions detected moonquakes, tremors of varying intensity. Some are shallow, caused by the expansion and contraction of the crust as it heats and cools in sunlight. Others are deep, possibly related to the slow movement of magma or shifts within the lunar interior. Unlike earthquakes, these quakes are mild, rarely strong enough to damage structures, but they can last for minutes, their vibrations echoing across the rigid crust. Studying them teaches us about the moon's internal structure, revealing layers and weaknesses invisible from the surface. The moon is alive, in subtle ways, reminding us that even the quietest worlds have their rhythms, and that beneath the still, silver landscape, there is motion, slow, deliberate, eternal. What the moon reveals about Earth's past. By observing the moon, we can trace the early history of our own planet. Its craters, maria, and ancient rocks act as a mirror, showing the chaos of the solar system when Earth was young. Impacts that scarred the moon also struck Earth, shaping continents, oceans, and the conditions for life. The moon's formation tells a story of a colossal collision, likely between the proto-Earth and a Mars-sized body, scattering debris that coalesced into the moon. By studying its surface, we understand the bombardment history that influenced the evolution of life on Earth. Its quiet, preserved landscape acts as a library of planetary memory, revealing events long erased on our more active world. In many ways, the moon is a guardian of Earth's earliest secrets, a celestial archive holding lessons written in rock, dust, and shadow. The perfect mirror for cosmic observation. The moon's far side offers an extraordinary advantage for astronomers, a shielded, silent stage for observing the universe. Free from the radio chatter and electromagnetic interference of Earth, it is a perfect vantage point to study faint signals from distant stars, galaxies, and perhaps even the echoes of the early cosmos. Imagine telescopes nestled in craters, their lenses pointed toward the vast void, capturing light and radio waves unbroken by the noise of human activity. The moon itself acts as a cosmic mirror, not reflecting our image, but revealing the universe in unprecedented clarity. Here, in the stillness of its shadowed valleys, scientists can listen to whispers from the edge of time. The moon transforms from a companion in the night sky into a partner in discovery, offering us a place where the secrets of the cosmos can be glimpsed without distortion, where the faintest signals from the universe reach us undisturbed, painting the history of everything in silvered silence. How the moon affects animal life on Earth. The moon's influence reaches beyond tides and human imagination. It touches the lives of countless creatures. Marine species, from corals to fish, synchronize reproductive cycles with lunar phases, ensuring eggs and larvae meet in the safest currents. Nocturnal animals often adjust activity based on moonlight, balancing feeding with hiding from predators. Even insects, birds, and mammals can sense its subtle cycles, aligning behaviors with waxing and waning phases. The moon shapes life through light, rhythm, and tides, weaving a gentle pattern into ecosystems across the globe. Its presence reminds us that Earth is not isolated. It is part of a delicate, interconnected system where a distant, silent partner guides motion, growth, and life itself. Each phase, each glow, is a quiet pulse, a rhythm against which all living things move, breathe, and flourish. The moon's slow disappearance into the distance. Although it seems eternal, the moon is slowly slipping away. Every year, it drifts outward by about 3.8 centimeters, imperceptible to daily life but profound over eons. This slow retreat alters the rhythm of tides, lengthens Earth's days, and shifts the dynamics of our gravitational relationship. The Earth-Moon system is a delicate dance, energy exchanged subtly, yet inexorably. Future generations, far removed from our time, will witness a moon slightly smaller in the sky, tides less dramatic, and the solar eclipses we know today impossible. The moon's slow departure is a reminder that even celestial bodies, seemingly eternal, are in motion, that the cosmos is not fixed, but a living, shifting tapestry. What feels permanent is simply a moment in a vast, unfolding story. What happens when the moon is gone? If the moon were to vanish, Earth would not collapse, but life would feel the loss profoundly. The tides would weaken, altering coastal ecosystems and ocean currents. Nighttime illumination would fade, affecting animal behavior and biological cycles. Earth's rotation might stabilize differently, subtly changing the length of days and seasons. Humans, too, would lose a celestial companion whose face has inspired myths, calendars, and dreams for millennia. Its disappearance would not only reshape physical reality, but also the rhythms of culture and imagination. The moon is more than a satellite. It is a cosmic anchor, a silent observer, and a guide. Without it, the world would continue. Yet something essential, a tether to our past, and a mirror to our sky, would be gone, leaving nights darker, quieter, and perhaps lonelier. Why the moon remains humanity's eternal companion. Despite the vastness of space, the moon has remained close, constant, and comforting. It orbits in silent companionship, visible to all, a marker of time, emotion, and memory. It connects us to our history, to myths and science, to exploration and wonder. The moon is a witness to humanity's first steps into the cosmos, to dreams whispered under starlight, and to the tides that cradle life on Earth. It teaches patience through its steady rhythm, humility through its scale, and curiosity through its mysteries. Even as we plan bases, observatories, and voyages beyond, the moon endures as a companion that reminds us of our smallness and our courage, our fragility and our ingenuity. It is, in every sense, eternal in the human imagination, a silvered presence that has guided us for millennia and will continue to do so, quietly, faithfully, across the endless night.